There is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Digit Sum. So this is the way the module looks. It gives you a series of different variables, in this case k, x, and z. Now z is essentially what our input is going to be. That's not going to change. Same thing for x. X is going to be the first thing that we need. So we need to pay attention to this module. And k, now k will actually change over time. But it's going to change in such a way that the answer itself never changes. So what exactly is our goal with this module? Well, allow me to explain. The first thing that we want to do is we want to find a series of different variables. And what we can do is, let's figure this thing out. So a is going to be equal to the digit sum of x plus 1. So it's going to be generally a large number. And the way that the digit sum works is essentially what we're going to do is we're just simply going to sum up all of the digits. So let's pop out our handy dandy calculator here. We're going to do 5 plus 5 plus 4 plus 2 plus 5 is going to give us a total of 21. And for a, what it wants you to do is a digit sum of x plus 1. So we're going to do a is equal to 22 instead of 21, sorry. That was the last year. Now, Yankee is going to be a bit interesting. Yankee actually wants you to take a look at a bunch of different stuff, including 19 times the remaining time in minutes. Now, at this point, what you want to essentially do is you want to pretty much note down k at this point. You want to note down at least 1k and do the 19 times the remaining number of minutes at that exact same time. So in this case, let's note down k is equal to 20. And let's say that we're going to do this equal to 58 minutes. So we're going to do 19 times 58. So just keep that in mind. So let's take a look. So 19 times 58 is what we're going to be multiplying this stuff by. Is going to be that. 13 times the number of batteries. We have, in this case, 2 batteries, so that's going to be just 26. I'm going to do that mentally. Plus 26. 17 times the number of modules on the bomb. Only have 1 plus 1. Excuse me, that's going to be plus 17, rather. DBID ports. We don't have any. We do not have any 2-factor codes. We're just simply going to skip over that. No unlit indicators. Last digit of serial number times 11 is going to be plus 66. Then the starting time in minutes, I started with 60. We're going to multiply that by 3, so it's going to be 60, 120, 180. Okay, and this total is going to give us Yankee. This is going to be 1391. Okay, and now what we need to determine is we need to determine delta, which is actually going to be quite simple. Delta is going to be equal to Yankee plus Kilo, and we're going to modulo this by A. And that's the reason why this changes, just because of the fact that there might be minutes, there might be minutes that are going to be changing here. So that's what the K accounts for, essentially. So that's what we're going to be looking at here. So let's do this. We have 1391 plus the 20 that we had from the previous K. And then now we're going to modulo this by alpha. So we're going to modulo this by 22. So we're going to be here for a while. Let's just hit the enter and let's just let it do its thing. That's getting close. And now what we want our total to be is we want our total to be a 3. So delta is going to be equal to 3. Now what do we do with this answer? Because now we get to the part of Zulu. Zulu wants you to input the smallest number such that the digit sum of X-ray plus Zulu modulo 1,000,000 is equal to delta. So now, essentially what we need to do here is we need to figure out a solution to that. So what we're going to add, so we're going to add X-ray plus Zulu. And what we want it to equal is we want it to have a digit sum of 3. Now what we want to do is we want to find the earliest number, the smallest number, such that the digit sum of X-ray plus Zulu modulo 1,000,000 is equal to delta. Now the first digit that comes to mind is, the first thing we need to do is we need to actually determine where we are headed. We need to determine the earliest digit that will give us a digit sum of 3. And this one actually is quite easy. One of the things that we can already realize is if we take a look at the current position that we're at with X-ray, we're going to have to go over, and we're going to have to go over 1,000,000 in this case. And the earliest number that would give us a digit sum of 3 is 3 itself, because it's only going to be just 3 that's being added. It's not 12, although 12 would definitely be a possibility. It's not 21, it's going to be just simply 3. So now what we need to do is we need to figure out how to get to 3. So what we're going to want to do is we're going to want to get 1,000,003. Let's do 1,000,003. And now what we're going to want to do is we're going to want to subtract this. We're going to want to subtract the X-ray from this value. So we're going to want to do minus 554,025. And this is going to give us a total of 445,978. And if we were to input this into the module, so 445978. Now, if we were to add this together, so in this case, we would take the 554025 plus the 445978, add this all up, modulo 1 million, and in this case, it would give us 3. Exactly what we would expect it to do, and it is the earliest digit that gives, it is the smallest number that that the digit sum of X-ray plus Zulu, modulo a million, is equal to the delta. It's very important. So, hopefully this makes sense. This module is a bit weird with how it words itself, but digit sum is referring to the sum of all the digits. It's not digital root, which you might be familiar with, is essentially just adding up until it's all one number. This is just simply adding up all the numbers and just getting that answer. So this should be our answer. Let's hit submit.
Very well done.
And just like that is a solved module. That's all there is to this module, but it is a little bit tricky, especially with some bigger numbers that you can get, that you need to think a little bit sometimes outside the box. This one was an easy example because it already started at over 500,000, and at that point it would be impossible to essentially have any sort of multiples of different types of 3s. Like there could have been, for example, if we started at like 59630, for example, we could go to 100,002, for example. That would be the closest one that we'd be able to get. But in this example, it started over 500,000, so we actually had a bit of an easier one. Now, obviously, that number doesn't necessarily need to be 6 digits long. It simply just needs to be the smallest number that reaches the earliest digit sum. That's essentially what we're going to do. Obviously from X-ray. So let's pop up one more example, and hopefully we can get some different things. 1 second, and let's pop it. Okay. So now let's, we don't necessarily actually need to determine the digits of all of these. We can actually simplify this and make our life easier. We don't even have to really worry about why. So let's take a look though. But just for the sake of the tutorial, I'm just going to write this stuff down. A equals, Y equals, D equals, and let's figure out what that equals. So what we have here is we have an 8. So the digit sum of X in this case is going to be equal to what? 1 plus 5. Plus 5 plus 3 plus 5 is going to be 19, plus the 1 is going to be 20. Okay. Next up, Yankee is going to be equal to this. First off, let's write down kilo. Kilo is going to be 8. And we're going to use 59 minutes for this. So 19 times this by 59. Sorry about that. Anyways. So, 19 times 59 is going to give us the total of 1210. Let's find the number of batteries on the bomb, which in this case is 0. We're going to add 17 because there's only one module on the bomb. DVID ports. Once again, we don't have any. We do not have any 2-factor codes. 7 times unlit indicators. We do have 1 unlit, so it's going to be adding 7 to that. So add 7. The last digit of the serial number times 11. This is going to be a 33. So plus 33. And then the starting time in minutes was 180 again. So because we started with 60, we're going to add 180. 3 times 60 is indeed 180. So now we have 1358. Now we're going to add the kilo that we had beforehand. So we're going to add 8 to this. We're going to modulo this by alpha, in this case being 20. So now we're going to do mod 20, which in this case, as you can already see, it's going to become a 6. Just like that, I was right. Okay, so now let's take a look and let's see what we can get from this, because this is actually a really interesting starting point. Now obviously 150000 is out of the picture. We already have passed this point for X-ray. We cannot go back. We need to go to the earliest number that allows us to. So pretty much 15000 is out of the picture here, which makes me believe that the next available number, simply because of the fact that we're not going to be able to get past, we're not going to be able to get to 6 until after the 100,000 range. makes me believe that our first number that we're going to be able to see is going to be 200004. That's what I'm thinking here. So now, what we want to do is we want to figure out the digit sum of this. And this one actually should be pretty easy to figure out. So we have, in this case, our total of 200,004, which in this case gives us the first digit sum of 6. So now, let's see what this does for us. So 200,004 minus this, so minus x rate, in this case 150,535, is going to give us a total of 49469. This is what we're adding to x-ray to give us a number with the digit sum. No, we're not entering 20004. We're entering the number that would add, if we were to add to x-ray, would give us that total. So we're going to submit this, and just like that is a solved model. Now, obviously, we both had really easy examples. Both of these had really easy examples here. But essentially, that's all you need to do, is you need to just think, hey, is there anything that would give us the numbers that we need, the sum that we need beforehand, or do we have to continue on forward? And what would be the first example? That's all you simply need to worry about, and that's all this module asks to do. It's a fairly simple module. It is just a bit funky and sometimes can be a bit tricky with depending on what numbers you get. So, as always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.